Hello and welcome to Animated Education. Today we are going to solve a few simple problems connected with our previous topic, units of measure. So, let's say we know that a formula of force is MA. So, and a force is, the units of force is newtons. Now, we are asked to express newtons in base SI units. In base SI units, newton is also an SI unit, however, it's not a base SI unit. So, a newton is equal to the mass of units, the units of mass is kilograms, so kilograms times units of acceleration is meters per second square, so meters per second square, and from this we get that newton is kilogram times meters per second square. This is our answer. Specific heat capacity is written as small c. We are asked to express specific heat capacity in base SI units. So we know a formula where heat is calculated as C times M times delta T. So this is temperature, this is mass, and this is specific heat capacity, and this is heat in joules. So from this equation we get that C is equal to Q divided by M times delta T. Now we can write that the units of C is joules divided by kilograms times kelvins. Now, joules is not a base SI unit, so we need to find an equation where that could help us express joules in base SI units. So we can look at this formula, where energy is expressed as mass times acceleration times height. Now, from this we get that joules is kilograms times meters per second square times meters. Now we need to put this in our equation here, and we get that the units of C of specific heat capacity is kilograms times meters per second square times meters times 1 over kilograms times kelvins. Now, once we simplify all this, we get that the units is, this will simplify, so we get this is equal to meters square over second square times Kelvin. So, specific heat capacity expressed in base C units would look like this. However, it is usually written as joules over kilograms times Kelvin, because that says a lot more about that material that we are dealing with than base SI units. So, consider the following. The Earth has a radius r that is equal to 6.37 times 10 to the power of 6 meters. Now you are asked to find its circumference in kilometers. In kilometers, okay? Don't forget it. So, we know that the formula to find a circumference is 2 pi times radius. So now we could simply put our numbers here. Pi is approximately 3.14. However, it would be more convenient to convert these meters here in radius in kilometers, because 2 pi is simply a constant. 2 pi is simply a constant. So once we do that, we would get that radius is 3.37 times 10 to the third power kilometers, because 1 kilometer has 1,000 meters, so we simply divided this number by 1,000. So now, once we plug our numbers in, we would get 2 times 3.14 times 6.37 times 10 to the third power. And this would give us 40,003.6 kilometers. Okay, this is kilometers. You probably don't see it, but I wrote it here. Okay, so now we need to round our answer, and we get that our final answer would be 40,004 kilometers. Now, let's say you are also asked to find its surface area in square kilometers. Now, as you can see, our radius is expressed in kilometers, so it's very convenient for us. Now, all we need to do is to find an area. So, a formula to an area, if we consider the Earth a perfect sphere, is 4 times p times r square. So we need to plug our numbers in. So 4 times 3.14 times our radius. Our radius is written here. So it's 6.37 times 10 to the third power square. Now, once you wrote all this down in calculator, you would get that this is 509,645,864 square kilometers. And we could round this up, and we would get this is equal to 5.1 times 10 to the 8th power square kilometers. How I got 8th power? Well, here. Calculate how many numbers are here, because I put a dot here. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 10 to the 8th power. And I also rounded this, so because this is 509, so this is approximately 5.1. Now let's say you also asked to find a volume. So a formula to volume is 4/3 times p r cube. So once you did all the steps, the same steps as I did in previous examples of this exercise, you would get that volume is equal to 1.082 times 10 to the 12th power cubic kilometers cube. So yeah, Probably the only mistake you could have made here in calculating this would be a mistake in putting our radius. So you have to remember that this is a cube, not a square, as while calculating an area. So, how many micrometers are in 1 kilometer? So, how you could do that? Well, we know that micro is 10 to the power of minus 6. So, this basically says us that in 1 meter is 10 to the 6th power micrometers. So, once we made that clear, we must remember that 1 kilometer is equal to 1000 meters. This is 1000 meters. So, in 1000 meters, there are 1000 times 10 to the 6th power micrometers. So this will give us 10 to the 3rd power, and our answer is 10 to the 9th power micrometers. Here is how many micrometers are in 1 kilometer. It's basically 1 billion. The fastest growing plant on record is, well, something that grew 3.7 meters in 14 days. What was its grow rate in micrometers per second? So let's say grow rate is R, and we are asked to calculate in micrometers per second. So we can say that grow rate, an average grow rate of this plant is 3.7 divided by 14 days. So this is meters per day. Now we want it in micrometers per second. So what we need to do is to take this 37 over 140. This is basically the same thing, I just got rid of this dot here. What we need to do is to multiply this by 10 to the power of 6. This will give us micrometers instead of meters, because 1 micrometer is 1 times 10 to the power of minus 6 meters. So we multiply it 10 to the power of 6 and divide it by 24 times 60 times 60. This is the number of hours in a day. This is how many minutes an hour has, and this is how many seconds an hour has. So once we calculated this, we get that this is equal to 4,625 divided by 1,512, and this is approximately 3.059 micrometers per second. That's our answer.